Hello everyone, dear authors and invited guests. Welcome to technical session 4D. Myself, Harsh Soni, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the ninth edition of this International Conference of Information and Communication Technology for Competitive Strategies 2024. This conference is organized in a hybrid mode. Physical mode was held yesterday on Jaipur, and today and tomorrow is the digital conference day. Like that means 20th and 21st of December 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. So in this session we have 10 presentations, and each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answers. On 7 minutes, I will raise a gentle reminder so that you can conclude your presentation on given duration. Still, if you have any query or any update, you can write it to me in the chat box. And there's a one request to all the participants that you may all please stay connected with us till the closing remarks so we can capture the good memories of this virtual conference. Just before start this session, I would like to introduce you all to the chair for the session, Dr. Priyanka Sharma. Dr. Priyanka Sharma is a professor and director of research and development at Raksha Shakti University, Ahmedabad. She is an experienced professor with 18 years of expertise in teaching, guiding, and motivating to the students. Her research experience of 6 years having publications in journals of repute, including InterScience, IEEE, Springer, Elsevier, and Taylor and Francis. She is a member of editorial board of various journals. Welcome you, ma'am.
Thank you so much. And now we may start. Fine. Best wishes to all the participants. Okay.
Yes. So starting with the first presentation, first we have Vidisha Pradhan, and she's gonna presenting on a comparative study of self-sovereign identity models for managing academic credentials. Dear presenter, you may please proceed with the presentation.
Yes, sure. I'm sharing my screen. Once it is visible, just let me know.
Yeah, sure.
Is it visible?
Yes, it is visible. Please make it full screen and go ahead for the presentation.
Okay. A very good morning to all of you. Good morning, ma'am. This is Vidisha Pradhan from Charusat
Good
University.
morning.
I am assistant professor at Charusat University, as well as I'm pursuing my PhD. And the topic on which I'm going to present today is self-sovereign identity models for academic credentials. Preserving the academic credential is actually a very tough job right now, and in terms of security, it is very difficult as well. So people are searching for various different ways in which we can preserve the academic credential in terms of security as well as privacy. So my focus of this conference paper is specifically on how we can preserve the credentials. In terms of decentralized identity, why we need decentralized identity? The reason is when we are having centralized system, we do depend on the third party. So there is a trust involved. And when we are moving towards blockchain, we don't need to put our data somewhere that is secured, as well as it is not going to be vulnerable. So once it is stored, it is always be there. Nobody can change the data. Majority of the cases, let's consider 51% attack. Blockchain, in terms of its foundation with respect to SSI, the basic characteristics of blockchain helps us to inculcate the model in terms of security aspect. One thing is decentralized ledger. The ledger is everywhere available. So those who are connected in the network, whether it is public or private, those who are connected in the network, everyone is having the same copy of the ledger. So everyone is able to check about the hash values and is there any alterations are there. If 51% of the users are agree with the changes, then only the changes will be reflected, otherwise it will not. So in that case, it provides the transparency as well as immutability. Because once the block is created and it is stored, it is not going to be altered anytime. So what happens is, if you want to do some changes, the new block will be created and then the new block will reflect the new data. So it provides the enhanced trust as well, because those who are involved, there is no single point of failure in the system, because nearly each and every node is having their own copy of document, so there won't be the crash of document in terms of blockchain. And if we are talking about challenges of the traditional credential management system, credential in terms of students' documents like their certificates, their transcripts, and everything. So document frauds may happen from some unknown universities also, as well as from the student side also. Then verification delays. There is a long process of verifying the documents. Because of that, we need to check the hard copy, we need to check the many more things. And even though after going for this rigorous survey, there are chances that we have not we have there can be the possibility that the data is not much secure. Yes. There is a issue of lack of student control as well, because students have limited control over their academic records. Every time things are not available with them, so there can be it can also be possible that whenever students require to store the data, it is not available and they want to show the data to somebody that is not available. So these are various issues. And yes, the most important is data privacy concern. If we want to show something to the users, it is not necessary show something to some institute or somewhere else. It is not necessary to show each and every data. Our concern is a student should be able to show only those data which is relevant to the institute or the organization he or she is going to move. So we are having one solution that is having the concept of self-souvenir identity, in which only the user, or we can say the student in our case, is the holder of the identity. Nobody else can steal their identity. So what we can do in that case is, we have three entities: issuer, holder, and verifier. Issuer is an entity that issues the verifiable credentials, such as university, or it can be some government agency. So we have decentralized blockchain in which holder is a student who is going to ask for their own identity creation. So issuer, who is a university, will create the identity for the student, and all the data of the student will be with that blockchain ledger. The individual who owns and manage the verifiable credential with the use of the digital wallet, he or she becomes the holder, and verifier will be the third person or the entity who wants to check or verify the document of the student. Like it can be some institute for in which he is going for the higher studies, or the verifier can be the company or some business or some organization which is going to recruit the person or the student, and for that process they want to check their records. And we have the decentralized trust network, that is blockchain, which facilitates the secure and exchange of verifiable credentials between all these three entities: issuers, holders, as well as verifiers. In terms of how we can implement the SSI for the student credentials, we are having few steps. While going through all these steps, we can reach to that particular segment. University issues the credentials, then the this university generates and issues the digital credentials, such as their transcript and certificates, as I have mentioned previously, signed by their own private key. So once it is signed with the private key, it becomes secure. Then credentials are stored in a blockchain in terms of some hash value. The actual data is stored in the wallet, but the credentials are stored in the blockchain in terms of the hash value. That is a cryptographic hash of each of the credential, and it is stored on the blockchain, ensuring the integrity as well as the authenticity. Then we have third thing, that is student wallet that manages the credentials through digital wallet that holds the SSI. Then the process of verification will come into the picture. When a student needs to share their credentials, they provide a verifiable credentials using a decentralized identifier. Then there is a third party who wants to verify the documents provided by the student. So this third party, such as employers or some other institutes, can verify the credentials by checking the hash of the blockchain. They are going to match the hash. If the hash matches with the blockchain as well as the hash provided by the student, if it matches, it means the data provided by the student is right. And our concern over here is we are not interested in providing each and every information. If we are talking about, if some institute is asking for their uh, degree certificate, so from that degree certificate, their concern is to know their CGPA as well as their name of the degree. They are not interested, if they are not interested in knowing about the students' other data like their date of birth or their institute's name or something, then we can share that particular portion of the certificate only. We don't need to share the entire data because each and every identity or each and every attribute will be stored individually in the hash value pair. Key
Dear
value.
author, you have last 1 minute for the presentation.
So I have compared a lot many SSI models which are currently in picture. That is EverID, Life ID, Sora, Self-Key, Hyperledger Indy, as well as Sovereign, which are providing these features by using a private blockchain or public blockchain. And there are some interoperability and scalability issue. And majority of are having the data privacy concern, due to which we have used the SSI. So choosing a right SSI model for the education is very difficult. These are three models which are specifically using the concept of securing the user's credential in terms of student data, that is Life ID, Hyperledger Indy, as well as Sovereign. They few of them are permissionless, that is public, as well as
Might be Vidisha has certain technical issue, network issue facing. Okay, till then, we are moving forward for the next presentation. Next, we have Devangi Trivedi, and she's going to presenting on empowering Caribbean entrepreneurship, the role of the Green Book Business Directory. Is Devangi here? Is anyone who's going to present this paper on behalf of Devangi?
Yes, sir. Paper ID 510.
Ma'am, is this your title?
Lead disease classification with deep learning, hyperspectral imaging
Yes,
perspective.
yes, ma'am. We are going to announce the name, announce the title name, then the author can present. Just a second. Okay, so no one is here from this paper title. We are moving forward for the next presentation. Enhancing realism in AI generated imagery by integrating multi-layer feature extraction with EN optimization. And this paper title will going to presented by Shreya Thukral.
Yes. Hi, am I audible?
Yes, Shreya, you're right. Please
Okay.
go ahead for the presentation.
Yes. So good morning to everyone present here. I'm Shreya Thukral, and I'm currently pursuing Bachelor's in Information Technology at Mukesh Patel School of Technology Management and Engineering at NMIMS. So I'll just quickly share my screen. Is it visible?
Yes, it is.
Okay. So the topic that my team and I chose was enhancing realism in AI-generated imagery by integrating a multi-layer feature extraction with GAN optimization. So basically, our paper is based on a study which begins with AI-generated images produced by Copilot, which is a cutting-edge large language model which serves as the initial input, and then we apply models like VGG16 and ResNet 50 to extract high-level features from the images to create a hyper-realistic synthetic human face. Now, the architecture we've mainly gone for is GAN, which is Generative Adversarial Networks. So it's a revolutionized computer vision feature that helps in creating highly realistic synthetic images. And specifically, there's a subsection of GAN that we've used called StyleGAN2, and it's known for generating human faces with unparalleled photorealism. So, what's so unique about StyleGAN 2 is that it gradually increases images resolution through training, allowing complex details to be identified in images. It separates large, intermediate, and small image details for high control over facial attributes. And its usual features are actually something related to aging simulation, expression adjustment, and identity swapping. But what my team and I did was something different, like something that's not been done before, and you'll see the results in the following slides. So the power of StyleGAN 2 is mainly because of a three-way feature that it uses. Firstly, it's highly controllable. This means that it enables generation of diverse, realistic images tailored for various use cases, and it allows to precisely manipulate and generate images with specific attributes or features. Second is latent space manipulation, which basically is like a high dimensional space corresponding to unique images. So StyleGAN also takes into consideration like the play of shadows and dimensions to make the image generated look more lifelike. And the last one is separability of tasks. So what this means is it's breaking down image generation into distinct manageable levels for better control and quality. So it starts with large scale details, then moves on to intermediate details and fine details. Large scale details would basically be your face structure and your face shape. Intermediate details would be like your nose shape or cheekbone structure. And the last one is fine details, which is like your texture, the skin texture, your pores on the skin, the discoloration on skins to make the image look more lifelike. Because again, these are synthetic images. So these people, the faces that are generated, these are faces of humans that do not exist. So basically, what our model does is it starts with image selection. So my team and I, we made a data set through Copilot. We asked Copilot to generate AI images which look animated. And after we selected these images, these files are renamed by our model, which is for easier management. And then the original files are discarded for maintaining workspace and like maintaining like the file structure. Second is image acquisition. So once the image is acquired from Copilot, we'll feed it into our model, and our model pre-processes and prepares the image for further processing. So the images are basically saved in a suitable format, and it also ensures that the person is only uploading one image at a time. After that, our model starts detecting the facial features. So basically for this, we used a DLib library, which is a face detection library, and the model we used was a 5-point landmarking face recognition ResNet model. And this model is basically a pre-trained model which is trained over like 7,000 images. So it's very good at recognizing facial features. But we wanted it to perform better on AI generated images. So that's why we used our own data set. Then fourth is we transform the images by using StyleGAN 2. So here the main processes are cropping, mapping to latent space, optimization, which is basically like iterative adjustments, balancing image quality and computational efficiency. Now, finally, the result would be the initial images generated using Copilot will be processed to identify key landmarks, which is like your nose, your eye corners, and like very starkly different features, which is unique to every human being. And then cropping and centering is done. Eye positions are used for leveling the facial size so that like there are no distortions in the face, like the proportions are very much human-like. And then finally, the cropped images are converted from BGR to RBG. So basically, Copilot generates the images in BGR, which is then converted to RBG using StyleGAN. So this is the entire workflow, and the results are basically like this. So you start off, the first row basically shows the images that we asked Copilot to generate for us. Then if you see in the second row, you can see like our model has highlighted the nose, the eyes, and all the main starkly different features of these people. Then it goes and it crops the images to take a closer look so that it identifies the features better. And then finally, the result is a pretty similar human-like figure of that AI-generated image. So we did our performance analysis on this, and basically, yeah. So basically, histogram similarity is used to compare color distributions in images using and yeah. So basically, what histogram does is it shows you the variations in the pixel intensity. So if you see this blue line, image one is basically a AI generated image, and the orange line is the human-like image. So it's showing like initially the differences in the color palette weren't very starking, and then suddenly there was like a much bigger difference. This was because the lighting and the color palette was more or less like transformed to make it look more human-like. Second is peak signal to noise ratio. So what this parameter does, it basically quantifies image quality by comparing it to original images. And the value we got was around 9.83, which is ideally considered average. But here the goal isn't to match the images perfectly, but to analyze how close they are to the AI generated images. So this value suggests that, okay, it's related, but it's not exactly the same, which you can see over here. Like you can map the images together, but again, it can't be the same because one is CGI and one is human-like. So then after that, the last parameter we chose was structural similarity.
Dear author, sorry to interrupt you, but you have last 1 minute.
Okay, all right. So this we basically used to assess the structural differences, and we got a value of 0.4, which indicates that the structures are pretty much the same, but the textures are very different. So the texture of this image is very different from this because this included all the discolorations, the contouring on the face, and everything was included. Now, moving on, we did a lot of research on other models, and the reason we chose StyleGAN was because of the high resolution image synthesis. Also, it has a feature called noise injection, which makes the images appear less artificial, and the other models were basically either too computationally expensive or not accurate enough. Now, this is used in features like entertainment, biometrics, retail. So in retail, when let's say your company doesn't have enough uh, money to like hire models, they can use our system to generate like real life human features and maybe like use it for clothes and accessories. That's the main purpose because like it's mainly for your face. So it's used in entertainment as well. It can be used in virtual reality, gaming to make like the uncanny valley, concept come to real life. And finally, our future research would be like, since this is such a easily accessible software, it could lead to like problems like deep fakes and stuff like that. So we need to kind of make it more restricted to a lot of people, since they can use it in unethical manners. So yeah, that was the entire project. Thank you. Should I continue sharing?
Ma'am, is there any question for the presenter? Priyanka ma'am, is there any question for the presenter? Okay, so might be there's no question from
No,
the.
no, we can continue, sir. Actually, म्यूट अनम्यूट करने में बहुत टाइम जाता है बस ये
Okay,
है
okay,
कि
ma'am.
kindly verify and validate more properly, ma'am, whatever you have represented. Okay,
Yeah.
now we may continue with it.
All right. Thank you.
Okay. Thank you, Shreya, for your wonderful presentation.
Thank you so much.
Now we can continue with the Vidisha Pradhan, where she has left her presentation. Dear Vidisha, you may please present your paper.
Yes.
Presentation last.
Extremely sorry, I was having network connection issue, and I was on my last slide only, that is conclusion. So when we are talking about self-sovereign identity, it is very much essential in terms of revolutionizing credential management with the educational institutes by leveraging blockchain technology plus SSI model. That's like a big thing which is useful for user-centric approach for managing the academic records. Future research should focus on real-world implementation and exploring the challenges and opportunities for integrating SSI into existing educational system. So I have done the survey so far, and now I'm planning to go for the implementation for the same in terms of implementing SSI on a blockchain domain. That's it from my end. Thank you.
Thank you, Vidisha, for your presentation. Ma'am, is there any question for presenter?
Sir, is my voice is audible?
Yes.
Yeah, just to know the future scope of the project, sir. That's the question.
In terms of future scope, I'm planning to create the private ledger in our institute only, in which we are going to go for this issuer holder type of structure at entity creation and all, and we are going to check the feasibility of how it is going to work for the institute.
So that's fine to listen from you. Thank you.
Thank you very much, ma'am.
Thank you, Vidisha. Now we are moving forward for the next presentation. Next we have Smitha Sasi, and she's going to presenting on healthcare assistance for paralyzed individuals based on hand gesture. Dear presenter, you may please present your presentation. Is there anyone for on behalf of Smitha who's going to present this paper? So maybe no one is available for this paper title. So we are moving forward for Onkar Kennel, and he's going to presenting on histogram shifting steganography for audio and video implementation. Onkar, are you available? Is there anyone on behalf of this paper title? Okay, so no one is available. So we are moving forward for Suraj Tomre, and he's going to present on IoT and machine learning applications in smart agriculture. Suraj, are you available? So next presentation we have.
Harsha sir, Harsha Soni.
Yes, sir.
Yeah, I'm Madhuri, Dr. Madhuri Guminene. My paper ID is 729. May I know when will be my presentation?
Ma'am, you just have to give me a minute. I have to check.
Yeah,
Till then,
yeah,
I can just announce the name of the next presenter.
yeah, yeah.
Yeah. Okay. So next presenter we have Bhavika N. Patel, and she is going to presenting on leaf disease classification with deep learning, a hyperspectral imaging perspective. Dear presenter, you may please proceed with your presentation.
So is my screen is visible? I am audible?
You're audible. Your screen is visible also.
Okay. Good morning, all. I am Bhavika Patel from Jaipur University, and today I am honored to represent my work on lip disease classification with the just a moment, with deep learning, a hyperspectrum imaging perspective, and at the 19th International Conference ICTCS 2024. Okay, the authors are the myself Bhavika Patel and Dr. Jitendra P. Chaudhary. So what is the these are the outline of my presentation, introduction, objectives, literature review. So why we are going for the hyperspectrum images? Because the India is based on the agriculture based country where the 70% people are depend on the agriculture. So if there is anything happen with the crop, it is directly affects our global economy. So to overcome this problem, if the agriculture is not harmed by the any pesticide or any symptoms. So for that, we are going for the identifying the disease on early basis. So for that, we are using the image based classification. So we are taking the images and we are going to classify the disease. But what happened in this one? So basically, we are using the RGB images. In that one, only three bands are there: red, green, and blue. And they have some specific limit of information. So for that, what we are doing, we are going to the multi-spectrum. Multi-spectrum, again, they have a limited band, like there are the 20 to 20, 10 to 20 bands are there. If we are going this one, we have to find out the some disease on an early basis. But if we are going for the hyperspectrum images, where the multiple bands are there are the 100 to 200 bands are there. So if you are going for the hyperspectrum images, it will give you the better early detection classification. Okay, so it is used for the early detection of the classification. So exercise has become a viable non-destructive method for early pattern identification in the recent years. Okay, so we are using the hyperspectrum images with the deep learning or machine learning algorithm to identify the disease on a plant which is not visible in a early stages. Okay, like we are human, if we are ill, we are or have some symptoms in early stage, but we are when we are ill more means when we become more ill, then we can identify if I have a fever or something else. So same way the plant have same of the symptoms in early stage also. So we can identify that symptoms and we can easily identify that one. So for that one, these are the some lip disease are illustrated over here, like what is the healthy lip is there. Then some mildew, powdery mildews is there. There is a powder form, white powder form is visible in your leaf. Then these are the blight disease. This is the downly mildew disease. So some of the diseases are there. So what are the objectives of my presentation, which are used to combining the deep learning technique with the hyperspectrum limb imagery for early pathogen identification and classification is to create an automated, dependable, and effective system that can recognize plant disease in their earlier stages. So these are the some literature review. I have gone through the multiple pages, around to 100 to 150 papers for my PhD work, but I am illustrating over here only 8 to 10 papers for the presentation. So first author is Kumar Yadav. Okay, he his studies focused on the detection of the CBC infected fruits and canker affected leaves using the ML and CNN. Okay, they use the methodology for the disease classification is PCA for the band selection. CNN models like Visual Geometric Group 16 and Softmax and SVM for the classification. The key results they classify the HSI images with the high accuracy for the disease and the condition differentiation. They demonstrate the use of the PCA and CNN in developing the commercial MSI system for plant disease detection. So the second method, second paper is authored by the Maxime Rekiweber et al. is to use the grip find lift. This is they are using the they are using the PCA and the hyperspectrum images for the data classification. They have achieved the 80.5.1 accuracy to classify the images if it is a damage or it is a healthy one. Then the next paper is Longwen et al. Okay, they also use the early plant disease dataset for to identify the disease. They are using the ML, machine learning, deep learning, vegetarian indexing, and image segmentation algorithms to for the classifying the disease in plants. They demonstrated early stage detection capabilities, and they are significantly underscore HSI's role in reducing crop loss and improving disease management. The next one is Dingajing et. Their studies focus on the rose black spot disease detection, and they are using the CNN HSI for the uh, classification. They also use the CNN models like AlexNet, which is the 16th NDDR CNN, okay, for the future fusions. They validate the CNN and future fusions as effective technique for the horticultural disease detection. The next author is Lai Jing-kyung et al. They use the oil palm seedling for the plant for the identifying the this is the or this is the infected or not. They are using the deep learning and hyperspectrum images. They are using the model VGC16 and statistic analysis ANOVA for the classification. They achieve the high classification accuracy for the healthy versus the BCR affected seedling. They demonstrated the potential for the HSIs and deep learning in the improving agriculture disease management. The next author is Liu-Sant et al. They are using the early detection of the bacterial wilt in tomatoes using the portable HSI. They use the methodology advanced feature selection, sequential feature selector, and SFS, sentiment analysis, genetic algorithms with the GA-SVM model. In that one, GA-SVM model show the highest accuracy. The next author is Jongmei Jo et. They use the grapevine leaf roll disease identification using the HSI. They use the methodology ANOVA, linear regression, LS, and SVM classifier. They show that LS SVM achieved the excellent accuracy for the early disease detection. They emphasize the non-invasive HSI as a precision viticulture tools for the disease management. Next author is C et al. They use the detection of the tomato gray mold disease using the HSI. They use the K nearest neighbor and C5.0 decision tree model for the classification and disease, detection of the disease. They achieve the high accuracy up to 94% for the healthy versus infected classification and lower 61% for the infection severity. They demonstrated the HSI's potential in early decision detection, but highlights the challenges in the severity classification. What are the methodologies I have observed in all the papers? Like for the data acquisition, they are use the high sophisticated camera. They measure the reflected across the 100 of the small spectral bands. Hyperspectral photographs of plant leaves are taken. Then the quality of the obtained data can be strongly impacted by the selection of the sensors and imaging parameters such as the illumination and distance from the plant. While the laboratory-based imaging system we are using, they offer the more controlled circumstances like field-based imaging technologies enable real-time data collecting in agricultural environments. So if we are taking the only laboratory-based, only they have to take some samples. But if we are going for the field-based imaging, means we are using the advanced cameras, so we can use the real-time data also at this any time moment. Then feature extraction. From these images, we extract the relevant spectral features, leveraging techniques like principal component analysis to retain critical data while reducing dimensionality. These steps ensures a comprehensive data set for the further analysis. Then the model development. They employ the deep learning tech architectures such as the convolutional neural networks for the spatial analysis, recurrent neural networks for the spatial spectrum analysis, and multiple models are there. Rigorous training, validation, and testings ensure the robustness of the models. And so these are the conclusion what we have faced from the what we have observed from the multiple papers. Our findings demonstrate the significant potential of hyperspectrum imaging integrated with the deep learning for early pentagon detection. This innovative approach minimizes the crop losses, reduces dependency on chemical treatments, and fosters sustainable agriculture practices. We believe that the research can be revitalization plant disease management, ensuring healthier crops and greater food security worldwide. So I thank you everyone. These are the some references what I have followed. Thank you everyone. If you have any questions.
No, ma'am. I think so. There's no question for your presentation.
Okay, thank you so much, sir.
Okay, so I just announced the next presenter name. Next we have Gaurang Roykar, and he's going to presenting on medical imaging approaches to diabetic retinopathy, a systematic survey. Dear
Yes,
presenter, you may please present it.
good morning, everyone. I'm Gaurang Roykar. Am I audible?
Yes, Gaurang, you are.
Yeah. Good morning, everyone. I'm Gaurang Roykar. I'm a final year student at Pune Institute of Computer Technology, Electronics and Telecommunication Department. This is our final year project, Imaging Approaches to Diabetic Retinopathy, a systematic survey. So diabetic retinopathy is a very common condition that occurs due to high levels of glucose in patient uh, of retina, which are analyzed by a trained doctor. There are four signs of diabetic retinopathy. First is microaneurysms because of abnormal blood leakage from retinal vessels. Microaneurysms are very small and appear as red dots with sharp margins. When blood vessels are broken by abnormal swelling, the blood creates another type is hemorrhages, which is similar to microaneurysms but is larger and clearly visible in retina image. More capillary leakage can create exudates, which are fluid rich in protein and cellular elements. They are often arranged in yellow spots and located adjacent to each other. So, diabetic retinopathy is divided into 4 or 5 stages: mild, moderate, severe, and proliferate. We will see this when we will see the classification. So why is diabetic retinopathy detection important? It is because India is diabetic capital of the world, and most of the research in this domain happens in India. So what are the challenges in this project? The limitations are mainly due to spherical shape of eye, leading to brighter regions in the center of the retina and dark regions in the border. Non-uniform lighting, low contrast, small lesions, microaneurysms, and presence of objects in normal retina that have similar attributes to exudates and hemorrhages, such as optic discs and blood vessels, make classification tasks difficult. Furthermore, the attributes of exudates, microaneurysms, and hemorrhages are characterized by different shapes that can be lost depending on image processing algorithm used. And another one which is common in any image processing is uh, very low amount of data sets and biased data sets, which will be discussed further. So there are 3 major approaches to solving this DR. Supervised learning, self-supervised learning, and which is now the most promising approach, and which we will implement in the future, which are transformers. So supervised learning, popular methods are CNNs. Uh, these require labeled data sets, and common architectures are ResNet, Inception, DenseNet. These excel in binary and multi-class classification. Although the methods are a bit older, the accuracy is good, but these haven't been proved in clinical trials. So if you look at binary classification in supervised learning, this gives the output in a binary format. There is DR and there is no DR. So popular model is normal CNNs. The best paper on this is by Zhu et al. This use CNNs with stochastic gradient descent to classify retinal fundus images as DR and non-DR. The model includes 8 convolutional layers with max pooling and softmax for binary output. Techniques like rotation, flipping, and scaling enhance the diversity of imagings, helping to reduce overfitting and improve model accuracy. IPAC's dataset was used. Many classification models are trained on large datasets like IPACs, which contain labeled images for normal and DR positive cases. Supervised learning models achieve high accuracy due to clean label data, but they require extensive training data and computational resources. Moving to multi-class classification. So 5 stages of DR that I discussed earlier are the outputs of this model. So deep CNNs like ResNet, Inception, DenseNet are popular for handling multi-class classification. The best paper on this is by Lee et al. Lee et al. Used ResNet 50 with additional attention modules to capture DR severity by focusing on lesion regions in fundus images. The model was trained on Mesidot and iterate datasets. My images were resized, normalized, augmented to improve model training and increase robustness to diverse fundus images. Yes, 5 grading classification. Challenges faced by them were labeling complexity increases with multiple classes, requiring carefully labeled datasets and enhanced model architectures to handle nuanced differences between DR stages. Self-supervised learning for DR detection. SSL reduces dependence on labeled data, learns feature representations from unlabeled retinal images. Example, cabinet uses category attention blocks for DR grading. Binary classification in self-supervised learning. Self-supervised learning involves learning useful representation from unlabeled data, which can be used to improve classification accuracy even when limited data is available. The best paper on this is by Liu et al. Used self-supervised fuzzy clustering networks to generate clusters with unlabeled retinal images, providing self-supervision signals for training the model. Feature learning, the model extracts feature from unlabeled images, which are then clustered to provide pseudo-labeling approach to binary classification tasks. Benefits of SSL are reduces dependency on labeled data, which uh, uh, which which is beneficial for medical applications where expert annotated data may be limited. Multi-class classification. Uh, he et al. Is the best example on this. Developed category attention blocks within CNN architecture to emphasize lesion regions in DR images, enabling accurate DR grading with SSL. Category attention block captures category specific features by focusing on spatial and channel attention, allowing the model to differentiate DR severity with limited data. Fuzzy clustering helps generate pseudo-labels for multi-class classification, where each image is associated with DR grade based on clustering pattern. Augmentation techniques like horizontal, vertical flips, rotation, and color shift improve robustness in SSL, allowing the model to learn from various aspects of retinal images. Useful for DR grading severity without exhaustive labeling, although achieving fine-grained classification in early SSL models require combining labeled and unlabeled data for refinement. Now, this is the current state of the art transformer-based approach. These require very less data set and give excellent accuracy. So best in this approach, the best is lesion-aware transformer developed by MIT. So vision transformers. These were originally designed for natural language processing but have been adapted to image analysis tasks. VIT split images into small patches and use self-attention to capture dependencies across the entire image, enabling both local and global feature extraction. DR detection. Transformer analyze complex retinal structures by focusing on different regions in an image, which is essential for detecting varying DR lesions. Self-attention mechanism captures a relationship between patches which help differentiate between normal and diseased retinal regions. High accuracy. Models tend to perform better than CNN on large data sets due to their ability to handle more complex relationships in data. Key components in vision transformers, patch embeddings. Images are divided into fixed size patches, which are flattened and linearly embedded for transformer processing. Multi-head attention provides broad context by attending to
Dear
multiple.
presenter, sorry to interrupt you, but you have last 1 minute for the presentation.
Okay. And position encoding adds spatial information, allowing the model to retain the relative position of features within the retinal image. This is the state-of-the-art lesion-aware transformer. Uses pixel relation encoder and a lesion filter-based decoder for weakly supervised lesion discovery. LAT enhances DR grading accuracy by focusing on lesion-rich areas, addressing specific DR indicators such as microaneurysms and exudates, effective in weakly supervised settings where labeled data may be limited. So GAN transformers is another subset. Synthesized fundus images generating realistic representations of both normal and DR affected retinas, reduces dependency on large labeled datasets by creating synthetic data which can be used to train or augment other models. Advantages over CNN: enhances interpretability. Transformers provide attention maps that highlight areas that model focuses on, aiding in model interpretability. Improved generalization. VITs perform well across diverse dataset, making them suitable for large-scale DR screening programs. Data requirements. Transformers often require large data sets for optimal performance, including self-supervised transformer for combining with GAN to mitigate this need. And they are more computationally demanding. So, coming to the conclusion, there are four tasks which are helpful in DR detection: blood vessel segmentation, lesion detection, and there are multiple lesion detection techniques by Lee et al., which are in this Lee et al.'s survey paper. And DR grading system, there are some mismatches over DR grading system also, but over the times these have been pretty standardized. The major datasets used are IPAX, Mesidor 2, IDRID. IPAX is the largest of them, but this is more skewed towards non-DR images. And IDRID is the one which is used which is procured from India. So these are the most important for our research. And moving forward, for feature extraction and better performance in transformers, two methods are important: knowledge distillation and feature extraction. Knowledge distillation is a powerful technique that enhances model performance by transferring the knowledge from a large teacher model to a student model.
Dear presenter, kindly conclude your presentation.
Okay. In conclusion, in this survey paper, we studied current approaches to detection of diabetic retinopathy using deep learning and machine learning, and we didn't suggest improvements, but yeah, we studied data sets, and we will be suggesting improvements in our project. and that would be their future scope. Thank you.
Thank you, Gaurang, for your wonderful presentation. Does anyone have any question for this presentation? Okay, Gaurang, thank you for your presentation. I think so no one has a question.
Thank you.
So moving forward for the next presentation. Next we have Usha Joglekar, and she's going to presenting on optimizing facial expression recognition through transfer learning. Dear presenter, you may please proceed with your presentation.
Yeah, thank you. Is my screen visible?
Yes, it is visible.
Yeah, greetings of the day, respected chairs and fellow aspirants. I'm excited to present our work titled Optimizing Facial Expression Recognition through Transfer Learning Insights from Deep Learning Architecture, presented by myself, Santosh Gandala, Renuka Agrawal, Usha Joglekar, Unnati Jha, Srushti Nagrale, and Varsha Iyer in affiliation to Symbiosis Institute of Technology. Our agenda includes introduction and background for overview and foundational context, motivation and literature review to rationale and prior research, problem and objectives of our research for key issues, gaps and goals of the research, followed by proposing a model, its design and implementation, then findings and implications as results and discussion, and finally concluding with key takeaways and future research purposes. Why facial expression recognition is important. FER are universal way to convey emotions, driving advancements in healthcare, security, etc. What is facial expression recognition and how does it work? FER identifies emotions using facial cues like eyes, mouth, eyebrows as a part of AI and computer vision. It analyzes features to interpret emotions like happiness, sadness, disgust, etc. using a pre-built or advanced algorithms, and applications of FER range from healthcare like diagnosis of mental health conditions like depression and anxiety, identifying of unspoken emotional cues, and coming to human computer interaction, designing any empathetic user interface, tailoring experience for their emotion, security, detecting suspicious behavior, spotting stress signals to prevent threats. And coming to education, monitoring student engagement and emotions during the lectures and personalized learning experience. Why there is a need for a new approach to facial expression recognition? The challenges while dealing with facial expression recognition are variability. Expressions differ across cultures, context, and it is unique for every individual. And the subtlety in facial expression. Subtle emotions are hard to distinguish, and for a computer, it's harder. As humans, we can't understand each other. How can we expect a computer to perfectly understand us? And environmental factors such as lighting and occlusion often blur the vision or obstruct the vision, which does not help it to perfectly detect or classify the emotion. Multimodal expression, mixed emotions require interpreting complex combinations. Advanced techniques like transfer learning are needed to improve facial expression recognition accuracy. And a little background to for better understanding the research. Facial expression recognition. FER identifies emotions through facial cues, aiding mental health, HCI, online learning, stress monitoring, etc. using computer vision and the algorithm it is trained on. What is transfer learning? Pre-trained models like VGG16 and ResNet 50 version 2 and fine-tuning other models for especially for facial expression recognition enhances the performance with limited data, reducing the computational expense and training time. What CNN? Convolution neural networks analyze visual data, detecting patterns like edges, textures using transfer learning. Our study improves facial expression accuracy. These are the motivations behind the research. Limited size of facial emotion data. Facial emotion dataset often lack the diversity and scale necessary for training a deep learning model effectively. Overcoming overfitting and improving generalizability. With small data sets, model risk overfitting where they perform well on training data but poorly on unseen or real-time data. Transfer learning mitigates this using feature learning from larger, more diverse data sets and to generalize it better. Transfer learning for enhancing accuracy and robustness. Pre-trained models such as those trained on large-scale datasets like ImageNet provide a strong foundation. Fine-tuning these models for facial emotion recognition enables significant improvement in both accuracy, robustness, and even on limited data. This is a summary of a literature review. Dataset use and limitations. Most of the researchers rely on CK extended due to its high quality images, labeled images across multiple expressions. The positive is that it provides a solid benchmark for comparison, but the limitation is its variability and it does not fully represent real world complexities. And diverse datasets. Techniques explored. Previous techniques like transfer learning pre-trained models like ResNet 50 and MobileNet version 1 are fine-tuned for facial expression recognition. The advantages are that it reduces the need for large dataset to improve generalizability. Example like Tian W et al. Said that MBCC CNN model achieved 98.48 accuracy using transfer learning with global and local feature extractions, whereas Akhand MAH et al. Fine-tuned a pre-trained CNN model resulting in an accuracy of 97.8, and the ensemble learnings combined prediction from multiple models to enhance model performance. As seen in Alm IN et al. Used ensemble learnings with data augmentation achieved an accuracy of 82.5. Advanced feature fusion. Adaptive feature fusion combines important characteristics improving detection accuracy. As seen in Zhu H et al. Achieved 98.87 accuracy using feature extraction and fusion methods. The challenges addressed in the literature are occlusion. Techniques like dual path networks, as seen in Quanti and Ingo et al., effectively recognized partial facial features and maintained performance as given by Kwan et al. Small data sets, transfer learning mitigates data limitations by utilizing pre-trained models that are trained on large and diverse data sets. And intrasimilarity, variability in expression within the same emotions in addressing using ensemble and fusion methods. Key results, the table shows the results of different models used and their accuracy. As discussed, key takeaways, here is a graphical representation of those models. Key takeaways. Transfer learning always dominates. It is the most effective approach for facial expression recognition, especially for small datasets. The art performed by leveraging multiple perspectives. The future scope is real-world datasets with higher variability are needed to push boundaries. Application in fields like healthcare, e-learning, and human-computer extraction offers exciting opportunities. Moving on to our problem statement, complexity and variability in human emotions. Human emotions are inherently complex and highly variable. Subtle differences in facial expression, culture variation, and context make accurate recognition a challenging task, and poor performance of convention systems on small datasets. Traditional machine learning systems struggle with small, underrepresentative datasets, leading to limited model performance and inability to handle real world complexities, leading to overfitting. Need for robust model for diverse real world applications. Applications such as healthcare monitoring, etc., and computer interaction require highly accurate and adaptive emotion recognizing systems. Existing solutions often fall short in addressing these diverse requirements of real world scenarios. Research gap analysis. Dataset limitations. The dataset is small and imbalanced data. Many existing facial expression recognition systems depend on datasets like CK extended and FER 2013. Limitations are that these datasets are small, typically containing fewer samples per motion category. and their imbalances. Some emotions are overrepresented, like natural or neutral and happy, while others, like fear, disgust, etc., have sparse data. This leads to overfitting and reduced accuracy when tested on unseen data. Underutilized pre-trained models, potential of transfer learning. Current research often uses transfer learning for large scale tasks but rarely adapts it for small scale emotion specific dataset. Lack of robust pre-processing techniques. Pre-processing needs. The FER systems require tailored pre-processing to handle occlusion such as glasses or lens reflections, hands covering the face, etc., variations in lighting and facial orientation. The generic pre-processing techniques are failing to address the dataset specific challenges. Real world applications are underexplored. Dynamic scenarios like real world applications in healthcare and education demand systems that can recognize emotions in dynamic and real time detection, which like non ideal conditions for any system. Moving on, research objectives are to
Dear presenter,
improve.
sorry to interrupt you, but you have last 1 minute for the presentation. Kindly conclude.
Okay, then I move on to. Yeah, this is a model proposed. The model uses a Canada extended dataset, one of the most widely referenced dataset in FER task. Key characteristics include 7 attributes: emotions like anger, disgust, fear, sadness, surprise, happiness, neutral variations. These are the pre-processing steps used. Grayscaling to reduce the computational strain. And transfer learning, we have used the models VGG16 and VGG19, MobileNet, ResNet 50 V2, and fine-tuning the already existing CNN models. Data split, the data is split into 3 parts: 70% for training, 15% for hyperparameters, and 15% for evaluating the model performance. Model training, we have used like optimizers, loss function, and batch size epochs, and followed by model evaluation and model performance. Here, ResNet 50 has a training accuracy of 99%, showing strong learning of complex patterns, and a testing accuracy of 95%, indicating its excellent generalization, and loss values low and stable during training and testing, reflecting effective learning. VGG 16, VGG 19, and MobileNet testing accuracies ranged from 85% to 92%, while MobileNet performing best due to its optimized architecture. Loss plots, ResNet 50 V2 has the smoothest curve, converging faster with lower loss, whereas VGG 16 and VGG 19 showed slower convergence. MobileNet has a moderate rate and error analysis. Error analysis is misclassification. Errors mostly in distinguishing similar emotions such as fear and surprise, sadness. Some errors caused by ambiguous or low quality images. Class imbalance, fewer samples for certain emotions like disgust in CK extended dataset impacted performance. ResNet 50 V2 has a superior performance. Impact of transfer learning. Transfer learning proved to be a game changer in this study. Leveraging pre-trained knowledge, these models pre-trained on ImageNet benefited from prior knowledge of general image features, requiring only fine-tuning for FER tasks. Small dataset adoption. Despite the limited size of the dataset, transfer learning enables the model to achieve high accuracy by reducing the dependency on extended dataset. Model robustness, the
Dear,
model
kindly
demonstrated.
conclude your presentation.
Yeah, it's done. Just one more slide. Challenges and limitation, data limitation. The limited size and diversity of the extended data posed a challenge, especially for emotions with fewer samples. This is a future scope, advanced data augmentation, and real-time FER cross-domain applications. Finally, to conclude, this research underscores the transformative impact of transfer learning in facial expression recognition system, especially when dealing with small data sets like CK extended by leveraging pre-trained CNN models such as ResNet 50 V2, VGG 16, 19, and MobileNet. The study demonstrates significant improves in model accuracy and robustness. These are some of our citations. Now I open the floor for any questions. Please feel free to ask.
Thank you, Santosh, for your presentation.
Yeah, thank
Do we
you.
have any question for this presentation? I think the session doesn't
Thank
have
you
any
for your
question.
time. Thanks.
Yes, thank you, Santosh. Okay, so moving forward for the next presentation. Next, we have Vidhi Jitendra Yadav, and she is going to present on user-centric e-commerce evaluating chatbot effectiveness in facilitating e-book download. Dear presenter, you may please proceed with your presentation.
Is my screen visible?
Yes, it is visible.
So, good morning, everyone. I am Vidhi Yadav, and I am a BTech student at Marwadi University. And today I am going to present my research paper. The topic is user-centric e-commerce, evaluating chatbot effectiveness in facilitating ebooks and downloads. So the abstract is this research paper explores the development and implementation of a website based on e-commerce platform designed to facilitate buying books, both physical and digital, and modern payment system such as UPI, and also cash on delivery is available, and along with the real-time chatbot support for the user interaction. So the context of study is the increasing shift towards e-commerce and online shopping platform. So the need of specialized platform focused on books with the modern payment system and user for the best user interaction. So the objective is to design implement a user-friendly e-commerce platform for books, and the problem statement is limited physical space for books. So our website is allowing to ebooks also. You can download or you can purchase it. So also slow customer service response time and the lack of 24/7 supports. Now for the literature review, key findings of previous research. So e-commerce in a book industry. There are many platforms which are available for e-commerce for the book, but they are having only e-books or they are having only physical books. So this website has both, and also it gives online payment, which is UPI and very modern type of payment. So also the chatbot integration, the use of AI powered chatbot in e-commerce platform has proven enhance user experience by providing intense support and personalized recommendation. So using AI, we made a chatbot which is 24/7 available, and it is easy for user to interact with this. So research methodology is for the approach. Full stack development approach was used to build this website, and the technologies are used is very basic, so we can manage the expenses for it. Uh, for front end, we use HTML, CSS, and JavaScript. For backend, PHP. Database is managed by MySQL, and the payment integration we use is UPI. So the main features are a wide book selection and a multiple payment option. Now data analysis from we analyze the data using users experience feedback. So we have done some survey and made a very good result from we get from it. Now result, if you're talking about result, then key findings from the research: improved user engagement. The chatbot was successful in reducing users frustration by providing quick response and personalized book recommendation. So for conclusion, so this research contribute to growing body of knowledge on e-commerce platform in the book retail industry in and the importance of advanced payment system and AI technologies. So the key takeaway are the platform successfully integrated payment system, books and customer support features. These are some references, and the feature direction or the feature scope is expansion of AI chatbot and introduction to mobile app for the increased user usability and integration of global payment gateway like PayPal or much more. So thank you.
So thank you, Vidhi, for your presentation. Okay, do we have any question for this presentation?
Yes, please. Good morning. I have a question.
Morning.
Just to add something. Vidi, thank you very much for the good presentation. I just wanted to know, your user, what was the level of what was the level of computer literacy for your user, in which you designed this website, and then what was the age group in terms of bibliometric, in terms of data? I want to know what was the age group of the user, and then what was the computer literacy level. Thank you.
So this website is for all the ages, like for from student to all all people who want to read books. So this is for the every group of age. Yeah. So because there is available of ebook also, and for the easy to use ebooks are much preferable.
Okay, thank you very much.
Thank you, Vidhi, for your wonderful presentation. Just a quick announcement for those authors who are not presented. Devangi Trivedi is here for the presentation. Okay, not an issue. Is Smita Sasi is here?
Excuse me. Hello, Susmita. I am the co-author of that paper. So, Smita Shashi, ma'am just had a medical emergency, so I will represent that paper.
All right, not an issue. Just a second, I'll announce the paper title. Okay. So Rahul Harsh is going to present the paper on behalf of on the paper title Healthcare Assistance for Paralyzed Individuals Based on Hand Gesture, right?
Yeah.
Yes, Harsh, please present your paper.
Yeah, sure. In my screen. Sure. Is my screen visible?
Yes, Harsh, it is visible.
Okay, so I'll. So myself, Rahul Harsh, I'm the co-author of this paper. So our paper is titled Health Care Assistance for Paralyzed Individual based on hand gestures. So let me walk you through our presentation. So what's about the research? So as we all know that India has a lot of population, and with a lot of population, healthcare facilities are also limited in India due to less supply of doctors in there. So one of the most common disabilities after stroke is paralysis. I mean, old people or many young people nowadays are getting it. So or the inability of a muscle to move. Regaining voluntary mobility can be facilitated for stroke survivors with ongoing therapy and rehabilitation. So what is the main purpose of our paper? The main purpose of this paper is to develop the system that will enable a person who has had a stroke or is partially paralyzed to communicate with someone in an emergency and not rely on the theme for basic necessities. So the basis of this research is hand gestures. So in paralysis, what happens that majority part of your body is paralyzed. No, the neuro impulse which transmits to our nerve, because you all know that our brain works on neurotransmitters and neuropulses. So that is affected in paralysis. So we had to our basic research was to develop a hand gesture by installing a device on the dorsal side of the hand, meaning the upper side of the hand. One can measure the tilt angle and use it to convey different kinds of messages. Additionally, it will be gathering real-time feedback on the patient's health parameters and altering the patient or his attendant anytime there are variations from the patient's typical readings on way of his health parameters. So what is the objective? The objective is to integrate real-time monitoring of vital parameters, including body temperature, pulse rate, and LED lights with messages alongside ordinary arms to ensure timely intervention and enhance health outcomes. So our main purpose was to come at minimum as possible because, as we all know, that paralysis can affect many people, and in India, most people can't afford that high quality of medical facilities. So we want to implement it in the government hospitals first to give a warning of early dangerous deteriorations, to facilitate early intervention and expedite emergency response for paralysis patients by leverage cutting-edge electronics centered on a microprocessor integrating advanced functionalities, including LED lights, buzzer sound, SMS notification to push the boundaries of what is possible paralysis care and rehabilitation. To develop solutions that not only improve health outcomes but also enhance overall well-being and quality of life. So this is our flowchart. We have a device on. So this is a body temperature sensor, normal reading, green light, abnormal reading, the red light, message displays LCD. So this is our flowchart. You can see we have developed it. So this is our hardware setup. This is a node MCU. We have a MCU terminal. We have analog to digital computer. We have 5-volt power supply to module, and you can see. Oh, sorry for that. We have acceleration sensor and all. So this is the perfect flowchart. This is just a flex sensor, breadboard, ESP32 microcontroller. Why ESP32? Because it has a Bluetooth module and a Wi-Fi module embedded in it. So messaging that and sending data to database becomes easier. So that's why we have used ESP32. And we have data processing and then forecasting. This is the architecture of a paraglove which will be embedded in the hand of the patient. So just is captured and interpreted by the ESP32. We then sends it over a Wi-Fi to Google Firebase. Google Firebase, as we all know, is a backend service, and it can be easily integrated by ESP32 when configured with proper credentials. The ESP32 updates the real-time database with recognized gesture by sending structured HTTP request to the Firebase API. So it is since we are using Wi-Fi module and internet for that, so we use the protocol HTTP request to fetch the API, fetch the API from the Firebase and get our results. So we can see the results here. This is the LED sense we have, and we get the messages here. Is it visible? This is the hardware setup. We have a ESP32, we have microcontroller Arduino also. So these are our references. So thank you. This is all from my side. This is our presentation. I say this is a novel presentation because we're helping paralyzed patients for that. And as we all know, healthcare needs a good innovation in India. So this is our presentation on our topic, healthcare as system for paralyzed individuals based on hand gesture. Thank you for thank you for allowing me to present. That's all from my side.
Thank you, Hers, for your wonderful presentation. Do we have any question for this presentation? So let's conclude the session. Okay, so I sincerely thank all the authors for their excellent presentation and the great contribution in their presentation and all the participants for being a part of this international conference. I hope this session was informative enough to all the authors. We, on behalf of the whole team, thank you for your support during this 9th version and all the previous 8th version of this conference. We will be happy to have you all in the 10th version of this conference in 2025. All the presenters would be getting the digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the stranger, and the publication will be live within 6 to 7 months. So kindly cooperate with the team of ICTCS 2024. So just before we end the session, I'd like to request you all turn on your camera so we can capture the good memories of this virtual conference. Kindly turn on your cameras. Thank you all. Thank you for your valuable presence over here. Thank you.